Hey, welcome to today's Houdini tutorial. I've mentioned before on this channel that I'm a bit obsessed with plants and organic structures, especially with finding ways to recreate them in 3D. After exploring some of Japan's stunning bamboo gardens, I felt inspired to bring that unique structure into Houdini. So in this tutorial, we will be modeling a procedural bamboo plant. As always, let's start with a quick game plan of what we are going to build. We will begin with a simple line and then give it some shape and thickness to form the base of the bamboo stalk. Next, we'll divide the line into segments, and for that we will use the Voronoi fracture. That will result in those slightly uneven chunks that make the bamboo look more natural. Once we have our segments, we'll refine each one to shape this iconic bamboo look. After putting all of them together again, we will find the connection points between the segments and use them to spawn small stalks with foliage, adding more life to the plant. Of course, we'll do everything in a fully procedural way, so you can apply it to any input line and easily grow your own digital bamboo forest. Let's jump into Houdini and build this thing. Here in our new instance of Houdini, we wanna of course start with dropping a geosop and name it bamboo. First, I would like to start with the base shape, which is a circle that lays on the ground floor, which will basically hold our bamboo forest. For this we scatter some points, and this number here is basically defining with how many stalks of bamboo we want to deal with for now. Let's say for now we work with 7, we can lower this relax iterations to get a little bit less spacing between the points. And let's color this blue. Okay, as I said, this will be our roots for our bamboo stalks, and for this I want to use a simple line, which I then copy to points. Like this, we will have them in here. We can also attach a scatter and align sop down here, connect both inputs and select add attributes to existing point cloud. And like this we can also start and scale them a little bit, maybe like a 0.8 and a 1.2, 1.2, and maybe overall scale it by 2. So our bamboos are a little bit longer. Okay, cool. Let's resample our lines like this, and let's output a curve view attribute because we will need this later on, which basically generates, if we come down here in the points, a float attribute that starts at the first point of the primitive and goes to the last one, and the first one will be assigned a 0 and the last one a 1, and everything in between, of course. And this we can use to our advantage in different kind of scenarios. Okay, let's work on our bamboo shape. For this, I wanna iterate on each of those lines individually. So let's drop down a 4 each connected piece. Let's drop it down, and here you can see we will get this special orange nodes that are already inside a container. And this means this is a loop. And in order for this loop to work, we need to, of course, wire it in and tell it on which pieces it should work on. Our connectivity sub in here will generate a class attribute on each primitive. So let's go in here, and you see we have from 0 to 6, and this refers our 7 total lines in here. I can drop a color or an attribute adjust color in here, and I can say a primitive and remap attribute, and put down this class attribute in here, compute the range, and you see each of those elements will be treated separately. And this is basically the same thing what this loop is doing. So down here, if I highlight it, you see we have 7 iterations, and I can visualize them with the single pass. So 1, 2, 3, 4, 5, 6, 7. Yeah, we can now focus on working on each element. What I want to do first is I want to shape our line a little bit to give it a bit of distortion in the middle in order for the bamboo to look a bit more realistic. Let's use a point warp for this, and let's say shape base, and in this point warp I basically want to bind our curve view attribute in here and connect the position to the position for now. But let's add a turbulent noise to the position. And remember, we have 0 and 1. I want to multiply it with this value, but from 0 to 1 it would mean it would gradually increase the distortion to the top. So we need to find a way to remap our curve view attribute, and for this I use this ramp node, set it to a spline, and I will multiply the outcome of our noise, which actually should be a 3D noise, together with our remapped curve view attribute, and I want to add in this kind of result into our normal position. Let's go into the turbulent noise and promote also the parameters that we are going to need and that we want to influence. And once we dive up one level, I will start putting up this ramp for the spline. You see, the first point will stay in its position, but the rest is going to wiggle into different distances. So let's move this point to the middle and lower the endpoint again. Select all of them and choose B-spline to give it a bit more roundish shape. And we can actually add another point in here to really make this kind of fade in and fade out. And of course this is a little bit too jiggly for my taste, so let's say maybe we do a simplex noise and we lower the amplitude and we also lower the... Let's go back with the amplitude and let's lower the frequency so we can tell what is happening. So yeah, let's go maybe for 0.4 maybe. Let's reduce the roughness and overall the amplitude. Maybe like this. I just want to have a very slight offset, maybe 0.2 in our bamboo. Because those bamboo stalks, they are quite stiff and less bendy, let's say. Okay, let's attach a sweep. Of course, Houdini is mad. Let's attach a round tube in here. Let's give it some caps. For my taste, this is a bit thick, so let's drop it down. Let's halve this value and let's apply some scaling along the curve to, yeah, taper it a bit to the top. Perfect. From our sketching session, I said we want to use the Voronoi fracture to really get some more irregular results in this kind of stalk. So let's drop it down already. Voronoi fracture, and it requires two different inputs. First is the geometry, but we will also need some points here that we can use. For this, let's make some room. I want to use our same point warp, but this time with some slightly different values in here. So I can put, for example, a 1 in here, and it will result in a slightly different bend of the line. But right now, each of our line would get the same kind of distortion. So I want to let it vary from basically iteration to iteration. And in order to do this, we can come into this first building block node here. We can say create metadata import node. This will add this guy in here, and in the detail section of the attributes, you can see now we have this kind of iteration value, which we can use inside our point warps basically. So let's offset our noise for each and every iteration. So we want to access those detail attributes, and let's jump out of this node, and we go for this for each metadata one node, and we are interested in the iteration. So we have here our metadata 1, and somewhere I misspelled, of course, detail, like this. So now if I click here, we are in iteration 0. If I put this to 1, now we are in iteration 1. Like this, each of our bamboo stalks will have a different kind of noise going through it and will be displaced differently. Let's copy our function here and let's paste it in here, and let's give it a random number to it. So this will also differ from the first one. Perfect. Let's shorten this path as well, because if we would wire it in now, the first cut would already happen at the top and at the bottom, and I don't want this. I would like to start it at this point and at this point. And for this, let's quickly group expression this thing. And here I have a cool one for you, which is called neighbor count. And this should work on our first input geometry and use the pt num. And I want to check if my points on this line have less than 2 neighbors, because this would result in the endpoints of this primitive. And of course I want to work on the points, and like this we have both of them selected, which we can now blast off like this. So now we have way less points, and we can of course also scatter some points along here, maybe not 1,000 but maybe 7, or ideally we can use this expression again, copy it, put it in our force count here with Option E. I can pop this out. Let's say we put it in here so you can see it better. And what we want to do is now randomize the number of points each and every strand will get assigned to. So basically our iteration number here that grows with each and every step, we want to randomize this number like this, and this would result in a 0 to 1 float number, which we then going to fit like the 0 and 1 number between maybe 7 points and 13 points. Hit apply and accept, and like this each and every step will result in a different kind of scatter in here, which then gives different kind of fractures for our Voronoi fracture. Let's wire it in, highlight it, and get rid of the single pass like this. And in the next step I would like to work on each and every newly created segments again. So for this we use another for each connected piece, and once we wire this in we will generate again this class attribute, which we could have a look at. Of course we just need to recompute this range here. We can also set it to completely to random and put here class inside. Yeah, like this is better. So the colors differ a bit more. And once we highlight this section here, we see we end up with 75 unique pieces. If I single them out, you can see these are the guys we're going to shape now. Let's focus on this guy. What I want to do in here is use a security fuse to really make sure our top face and our side faces are glued together. And now I would like to get rid of those lines in the middle. In order to do this, let's try to find a nice way to group them. Let's work on the edges. Let's include the edges. Sometimes it helps to check this maximum angle already. Yeah, that is doing the trick for us. Let's call it edges, and let's dissolve those edges like this. The cool thing, and why we settled with this Voronoi fracture, is it will already spit out an inside group and an outside group, which we can now address in our reshaping of this section. So let's attach a poly extrude node like this, which will work on our outside group. And what I want to do is now add some subdivisions at the corners. So I want to insert this a little bit, maybe by 0.01. Yeah, that looks quite good for me. And let's output this group and call it side. I want to do the same for this cap section. So let's copy this over. This time I don't want to work on the outside, but of the inside section. The same inset and call it cap. And now let's move those caps in a bit with another poly extrude. Move caps. And here I want to use my newly created group and just lower the distance a little bit, maybe a 0.2. Yeah, which is double the amount of this. And maybe let's give it also 2 subdivisions. So these lines lay on the same height. Perfect. Now let's also move in our side group a bit. So we use the poly extrude again. Like this, we want to work on our sides. And for this, I want to use this transform extruded faces and I want to scale it to about 90%. And this will give a bit more this iconic bamboo structure. Let's bevel our edges at the top there because they are quite harsh. So let's create a group again, call it bevel, use our edges again. This time we use minimum and maximum edge angle, and I like to start at 89-91. We need to work on the edges and we almost have all of them selected, but let's lower this section a bit and let's increase this one a bit just to make sure we always have them selected. Let's save and let's put a poly bevel node. This is the point where Houdini likes to crash. Let's select our bevel group and let's go very low with 0.35 maybe. Yeah, I think that's quite cool. Just to add another segment up here. Let's have a look how our geometry looks subdivided. Maybe 2 iterations. You can already slightly see our iconic bamboo structure. I think it can be more pronounced, and what I want to do for this is use a crease sop. And this will basically add a crease attribute, which is then read by our subdivide node, and it tells it to maintain the shape a little bit better. Of course, now all our edges get this attribute, and you see it maintains more this octagon shape. I don't want this, I just want to have it more pronounced on these areas up here. So I think what we can do is in our poly bevel, we just want to get those edges up here with this offset edges group, which we can then put into our crease. And you see, we get this slightly more pronounced top and bottom section of it. That's exactly what I want to do here. So next up, let's think about the shading already of our bamboo. And in order for it to look more realistic, I want to color it already. But for the color, I want to use a measure sop, which works on points. I don't want to measure the area, but I want to measure the curvature of it. Let's maybe up this a little bit, maybe like this, to get different kind of values for each part and then color them accordingly. So let's take our curvature, can also attribute blur it a bit, put it in here, and the attribute should be curvature. Let's append the attribute adjust color like this, where we want to remap our curvature attribute. Highlight it, and I think the 0:1 ratio is fine for now. We could remap the attribute, but I think it's not needed right now. Let's just use better colors. So let's go for a bit more of a lime green tone that looks a bit more bambooish. Yeah, maybe something like this. Let's go a bit darker at some areas like this, and in some other spots we want to go a bit more into this brownish direction, which will be the areas where the bamboo maybe bumped into other stalks of it and the green rubbing off. Let's go with that, and on our attribute blur in here we can play a bit with the blurring iterations and really adjust the look of our bamboo segment. For good measure, let's append a Labs Auto UV at the end to get some UVs for proper texturing later. And like this, you can add a null and say out bamboo base. Cool. Let's get rid of our single path and let Houdini cook our entire bamboo structure. Like this. And as you can see, they vary in size, in angles. And yeah, overall a pretty cool look. But let's shape it a bit more. Now I want to find those connection points in here and spawn different kind of little sprouts or stalks that grow out of there, which will then hold my entire foliage. That gives this bamboo forest a bit more of a foresty look. To do this, we can come up here at this part and we want to basically use our inside group. So let's blast it off and let's delete the non-selected. And you can see, maybe I switch the background to the dark gray in order for you to see it better. We have a lot of those intersecting surfaces. I just want to have one of those faces, so we can group it again. We can call it upward facing, and the primitives I want to select by its normal, which is facing in the y direction. Let's lower it again and let's blast off our upward facing, or let's invert it. So we are left with the upward facing faces in here. Perfect. I also don't need all of those elements because I don't want the smaller stalks to already sprout out of the bottom. This should be more like in the middle section of it. For this, we come in here and use our curve view again, and we use another blast node. And we say it is our curve view blast, wire it in. And in here, I want to set add curve view is smaller than 0.4 maybe. And I want to use it on points, of course. And you see we got rid of a good chunk of elements here. And I want to do the same stuff for the top parts. So I want to blast off, let's invert this symbol here, everything that is of 0.8. And you saw we got rid of some other things as well. Okay. These are defining our look again. This is defining our look. These guys defining our look. Yeah, just for the sake of it. What I want to do now is for each of those elements, and I dropped our buzzword again, for each, this time it's just a primitive. I want to find its middle point and subtract basically this middle point from the outer point position in order to generate an outward facing normal of each and every segment, which we then can copy our strands to and make sure they shoot out in the direction that we want. Okay, let's build this real quick, and for that we will write a little vex code in a point wrangle like this, and we say create normals. As I said, I want to have the middle point, which I can basically get by extract the centroid. Let's work on a single element again. Yeah, this one. So if I extract the centroid, there it is. That's wired in this second input here. And let's get its data. It will be a point, so it's a vector, and we call it midpoint. And it will equal our point function coming in through the 0 first input. I'm interested in its position data, and its point number is 0 because it's the first point. So for our normal, we add n equals our point's position minus the midpoint. And let's highlight it. You can already see the shading is a bit messed up. Once I toggle on the normals, everything is perfectly shooting out. And if we uncheck it and we check it for all of them, they're perfectly looking outside. But for now they have the same size as the bamboo, so I want to shrink them down a little bit. I will use a peak sop for this. Attach it here. Let's remove this. We compute normals, otherwise everything we did before is obsolete. let's check our single piece again and come in the peak. And let's lower it a little bit, maybe like this. Cool. Let's toggle on all of them again and let's attach a group. In this group, I want to work on points and just select a random number of points. Like a very low number. So we select different kind of points across our elements here. Actually, we could also resample our shapes here. Subdivision curve 0.01 to give it a bit more round appearance. Peak it, get it here, and say here, this is our random points. Like this. Okay, cool. Attach and all. Let's say out PTS foliage. And let's copy our new sprouting stalks to it. So let's attach another line here. And let's use a copy to points to copy the line over. Of course, it's oriented very wrongly. So you want to lay it down in the Z direction in order for it to face outwards. And now it's still copied to each and every point. So in our target points, we want to select just our randomly selected ones, like this. They're a bit too straight for me. I want them to shoot upwards. So let's do a bit of modeling and reshaping of our line. Let's attach a resample to have a bit more points to work with. And in another point warp, I want to basically, let's turn on the curve view, of course. In this another point warp, I want to jump inside and again use my bind node to get our curve view attribute into my warp, and now address the Y component of each and every position along the line and push them upwards. So let's split up this vector from vector to float. And then we use a float to vector like this. And we use our X and Z component that should not change, but we take our ramp parameter again, put it into our curve view attribute so we can remap it. And we will basically add this section into the Y component. Let's jump out and let's push this one up. You can see we can model our curve like this. Let's also set this to B-spline in order for it to make a bit more this kind of organic shape to it. We can also shrink our line a little bit like this and attach another resample at the end and maybe say subdivision curve to make it flow a little bit nicer. Perfect. Let's check what we did. Yeah, that looks way better. Maybe we can also attach an attribute adjust float in here in order to randomize our p-scale attribute a touch. Maybe 0.03 and 0.6. Yeah, let's go with this for now. It's also a bit too much for me and play a little bit with our seed. But I saw sometimes there are some that do some weird stuff. Convert line. And we connect the path. Yeah, that should fix it. I guess there was a weird thing happening that one of those elements here was not really closed once I resampled it. And with this, we just make sure that the path is always connected. And then the normals get calculated nicely. Now let's work on each of those elements again. And now we will build our most complex loop, which will basically contain all three elements that we did beforehand. So let's drop down for each connected piece in order to work on each of those elements individually, like this. Now let's make some space here. And first and foremost, I want to do the same like up here. I want to generate a fracture of these elements, sweep them, and make them look more interesting. So let's wire in our stuff down here. Now we are in this part of the loop. Let's create a metadata import again and update our expressions to this name. So this begin 4 now. In here we can select this one and just put a 4. This one as well. Begin 4. And then our scatter, we also want to have the begin 4 in here. Let's save this for now. We can also get rid of our point warp here. I don't want this to jiggle around too much. I think our sweep is quite fat, to be honest. Let's drop this down maybe to 0.1. Yeah, that looks better. And now we have our Voronoi fracture in here again. We can also lower the amount of elements, maybe between 5 and 8. Like this. Let's shape those elements, and for this we can basically take our entire section from here. Let's copy it and connect it, and you will see now we nested this loop inside this one, and Houdini will go through like, okay, I work on this element, I fracture it, then I take each and every fractured piece of this and go through this chain. I think we also need to make some adjustments here. For example, our side node might be also a bit too much. So let's halve all the values in here, because this is way smaller. We're not ending up with some funny results. The bevel, of course, let's tone this down also quite a lot. And let's look at our end result here. Let's say null. Bamboo structure like this. Yeah, that looks quite cool and just gives it a little bit more interest, I would say. Let's find our connection points again. Can use this entire section here. Wire it in down here. So we have some points on these areas. Let me scatter some points in here so we do things a little bit differently. Let's also use just a bunch. We can basically take this expression, put it down in here, color it also blue, so we have a random number. Let's attach a point wrangle. Let's create another normal here. That should also go into the Y direction like this. I want to copy some, again, lines to those points. Copy the points like this. But of course this looks super weird. Let's attach a scatter and a line. Sop again, wire it in, say add to existing point cloud. And in here we can crank up this maximal cone angle like this, so we have some other little stalks that stand out of here. We can reduce the scaling, randomize it, and also use maybe the global offset to get different kind of results here. Okay, let's resample those guys again, and let's use a tangent U attribute, which will basically look from each point to the next one. But I want to misuse it a bit and save this tangent U as a normal attribute. So now our normals will follow the path. And what I want to do here is scatter another points. Let's use our expression again. And this will be our points for our leaves. So let's say we want to have between 13 and maybe 23 leaves on each of those elements. Let's put down a lapse simple leaf, which gives us a very quick result. We can come in here, shrink down those width a little bit. Inside the shape, let's reduce the banding as well, and let's copy them to our points in here. course, they are way too big. So let's put the scatter and the line sop again, wire in both of the inputs, and in here set it to the point cloud again, randomize the leaves, maybe overall we will drop it down. And in the minimum and maximum angle for a rotate around the normal, we can put 360 degrees, minus 360 degrees. And what we can do now is merge our leaves with a swept version of our little stalks here. So let's set this to a round tube again, lower it quite a bit, maybe give this one a grid at the end, merge it. Oh, I think it's still a bit too much, maybe 4, maybe 3, like this. And we can also scale it along the curve and lower the tips even more, like this. Let's merge both of our things here together, put it out, and let Houdini cook it. Perfect. So let's attach a null in here and say out details. And for our entire bamboo structure, let's object merge our bamboo base up here together with our details. And we can call it out bamboo. Highlight it, center it, and you can see we have a nice little bamboo garden with foliage attached to it and different kind of patterns for each and every bamboo. Maybe let's jump back to a day's scenery here like this. And of course, now it's up to you to come inside and really shape the look of it. Maybe we can have even more bamboo strands. Houdini needs to cook this for a little bit, but then applies our entire loop structure to each and every new bamboo plant, and our forest gets a little bit more populated. I hope you found this tutorial useful. I would love to see you in the next one. To not miss out on it, please subscribe, please like the video, and enjoy your nice Zen moment with your bamboos. Cheers and goodbye.